Thank you all for coming. My name is Jonna Vance, and I'm from Arizona, and I'm going to talk to you today about value perception and a little bit about how that relates to social disagreement. Oh, I pushed the wrong button already. Let's go to present. Great. Okay, so we need to evaluate our environment to navigate effectively, to rapidly, effortlessly answer questions like, is this a good option or a bad option for me? Is this thing helping or hindering my goals? What path will be rewarding? So this comes up a lot as beings that are navigating our environment. So it's not surprising that our affective and emotional systems rapidly evaluate our environment for us. Traditionally, emotion is described as an agent's reaction to her perceptual experience or her other mental states. First, you see the bear charging, and then on that basis, you have a negative reaction. So on this traditional view, affect is not at the ground floor of the mind. It's something that happens after and in response to perception or imagination or thought. Sense perception tells us about shapes and textures, distances, and other sorts of things, but not values. So in this talk, I'm going to challenge that tradition, and I'm going to argue for evaluative perception, which is the claim that human perception, although I think this will extend to non-human animals as well, but we'll focus on human perception, represents evaluative features. So the goodness and badness of things and situations. And it does that in the contents of our perceptual experiences alongside things like representing shapes and colors, textures, and so forth. Okay, so here's the overview of what we'll go through today. Well, first I'll tell you a little bit about why I think this matters. Maybe you're already interested, but hopefully I can get you even more interested. Then I'll give you some examples. We'll just start with examples to get a feel for it, but then we'll talk about a more rigorous way of arguing that perception is evaluative. Then we'll ask a further question, which is, so we have something in perception that's evaluative. How do we know that it's a content of perception, something that perception is accurate or inaccurate relative to? And there I'll discuss some other psychological data on feature binding and valence. Once we have all of that picture, we'll have established evaluative perception, except we won't really know much about what exactly perception is doing when it's evaluating. We'll know that it's evaluating, but we won't quite know what the contents really come to. And so I'll spend a significant part of the talk talking about valence and accuracy. How can we give accuracy conditions for evaluative perception? After all, and I'll come back to this later, it makes sense to think that a perception of a red square is inaccurate if it represents it as a green circle, because the square really is a square and the perception says that it's a circle. But how does that work for value? So we'll come back to that. And then lastly, I'll talk about how evaluative perception might interact with and at least partly help explain social disagreement. It won't by any means explain all of social disagreement, not by a long shot, but it will help us at least have one more tool in our toolkit to deal with social disputes. Okay, so why care whether perception is evaluative? So I love thinking about perception and what it does and why it does those things. So if you care about perception, that already gets you on board, but maybe you don't already have a sense for why it's important. One thing that evaluative perception could do is it could provide a foundational source of evaluative evidence and knowledge. There's a long-standing question in philosophy, especially tracing to David Hume, thinking that you can't get ought from is. You can't get evaluation from description. And if all perception does is describe the world, the shapes and colors and textures, it can never tell us why something is good or bad, or that it's good or bad. And so then it leaves us questioning, how do we get there? But if perception does tell us things about what are good and bad, it helps us get a toehold into the evaluative realm. A second reason you might care is that evaluative perception can tell us about the rich decision-guiding functions of our sense perceptual systems. So I think probably the main thing that perception is doing is helping guide us around. After all, being an embodied organism, most of what your brain is up to is trying to figure out where to go, which things to do, and so forth. But that has to do with value, because you want to choose the best path, or at least a good path, and avoid the terrible paths. If perception can help us with that, that's important. We should know about how it does that. And lastly, evaluative perception can help explain why value disagreements can be so difficult to resolve. I want to really emphasize help explain. It doesn't do all of the explaining. There's lots of explaining to do, but maybe it can help see another way in which evaluative disagreements are difficult. Okay, so let's talk about examples of valence in perception. First of all, what is valence? So I'm going to use that term throughout the talk. It's an important term in affective science. The core notion here is called phenomenal valence, and really it's just pleasure and displeasure. So when something is pleasant, that's a positive valence. When something is unpleasant, that's a negative valence. So an experience is phenomenally valenced just in case what it's like, or the kind of conscious feel of undergoing that experience, is pleasant or unpleasant. But also, and this is part of the work of this talk, I want to add a gloss and say that while that's the core notion, we can say also that the experience feels good or bad to some degree. There's also functional valence. So functional valence is a role property, a kind of functional property, for which phenomenal valence is a phenomenally conscious realizer property. In other words, we want to have this on the table because not all valences in perception or elsewhere in the mind are consciously felt. Sometimes there's assignments of good or bad that are going on under the hood, as it were. And so functional valence is the general concept that's functional, and then when you have an actual feeling of that, that's phenomenal. Lastly, we want to have a notion of stimulus valence. Stimulus valence is how we talk about certain stimuli being good or bad, pleasant or unpleasant. There are whole systems in psychology, like the International Affective Picture System, where psychologists catalog normed responses to different pictures. And in those kinds of systems, things like spiders and guns and assault scenes are all negative because they generally tend to result in a negative response. People rate them negatively. And things like hearts and flowers and hugs are positive. Okay, but that's stimulus valence. It doesn't tell you what any person is feeling on a given occasion, but it gives you a sense of the disposition to cause the phenomenal valence in normal observers under certain conditions. Okay, so here's some examples. Stub toe. Hector stubs his toe. This causes him to have a very painful and unpleasant perceptual experience of the toe he stubbed. We often think of perception in philosophy as external perception, exteroception, but there's also perception of one's own body. And I think that's the first place to look for valence perception. Lots of pains that we feel in our body are pleasant or unpleasant. And if those are forms of perception, we already have a kind of valenced perception. Durian. So traveling in Asia, raise your hand if you've ever tasted durian, the fruit. Okay, you're lucky. Lindy tries durian for the first time. Her sample is from a rather large and pungent variety. It has an overwhelming smell of stale vomit, delicious, mixed with the odor of gasoline and raw sewage. Wow. Lindy finds the experience of smelling durian to be extremely unpleasant. Now notice this is from Matt Fulkerson in a paper on emotional perception. So Fulkerson is saying it's the experience of smelling the durian. Now there's an ambiguity there. It could be in the smell itself, or it could be in the reaction to the smell. So that's part of the point of this talk. You can't just get valence perception by saying it smells bad, therefore obviously perception is valenced. You have to do some more work, but at least that's a starting point. Okay, last one, violence. While walking across the street, you witness a person push another in an attack. The sight is deeply unpleasant. This is a still image from a real attack in the UK. An older man was walking in the street alongside other people on a normal day, and out of nowhere, someone just violently pushed him to the ground. No one knew why. The person was put in jail for a few weeks, but that attack, if you witnessed it, might be deeply unpleasant to see. Okay, so those are our examples. And there are lots more, but let's start with those. Let's keep those as our core. Examples are helpful. When we teach our students, when we sort of think through a problem, we kind of want to anchor ourselves to some of our key examples. But they only take us so far. They only get us started. We need rigorous criteria to support the claim that there's valence actually in perception, either in perceptual processing or in perceptual experience. And so that's part of what we'll do now. So we'll turn to the hallmarks of perception. Okay, so this is a technique for identifying elements of perception that is kind of cutting edge. It's not like it's never been done before, but in the last, I would say, 5 to 10 years, it has really taken off as a way to try to demarcate a principled sort of class of things that count as perceptual. After all, we use perceptual language to cover lots of phenomena. If someone makes a good philosophical point, you could say, I see your point, but you don't literally visually see the point. It's some metaphorical use. So how do we get away from metaphor and into what perception scientists are studying in the brain as perception, a kind of principled distinction? So what are the phenomena that mark a phenomenon as perceptual? Well, many perceptual phenomena exhibit these hallmarks, which we're going to talk about. And many non-perceptual phenomena don't exhibit them. So it's a kind of rough and ready guide to what's perceptual and what's not in perception science. And so our rule of thumb will be phenomena that exhibit all or most of the candidates to be perceptual. Phenomena that exhibit few or none of them are weak candidates. And what we're going to find is that speed, automaticity, subtle display sensitivity, repulsive adaptation, and rivalry advantages are all things that valence in perception exhibits. And so it's a good empirical sort of case for at least giving more criteria to the claim that there's valence in perception, that perception itself can be pleasant or unpleasant. Okay, so here, we'll just go through these quickly. This talk isn't primarily a psychology talk, so I'll just kind of give you a feel for this. And if in question and answer period you want to ask more details about these studies, I'm happy to talk about them more. So one set of researchers found that subjects who viewed pictures from the International Affective Picture System that I mentioned showed modulations in their brain using ERP neuroimaging recordings during the earliest phases of sensory processing, both the earliest regions, kind of primary visual cortex, and at very fast speeds, under 100 milliseconds. Okay, so that's one kind of source of evidence. Another thing is automaticity. So we often perceive things without trying to, and when it's not relevant to the task. So the idea here is sometimes we're given a task in a lab setting, and if someone extracts the information, even though it wasn't part of the task, that's an indicator that it's perceptual. Okay, so participants searched for a target face among distractor faces. And the goal was to indicate whether the target face was tilted left or right, so orientation, which is a classic visual feature. What the researchers found was that the presence or absence of a valenced expression, so a fearful negative expression or a happy positive expression, in one of the distractor faces significantly slowed reaction times. So you can see the black bar is much taller, representing longer reaction times when compared with neutral distractor faces. That suggests that the visual system is picking up on the valence of these faces, even though that isn't part of the target stimulus, and it's not even part of the task, because the task is orientation. Okay, so that's automaticity. Repulsive adaptation is a phenomenon where, after adapting to one feature in a certain direction in feature space, an after image or an after effect occurs in the opposite direction of that space. So for example, in motion perception, if you look at a waterfall, the water is flowing downward, and if you stare at that waterfall for a minute or so, and then you look at the rock face next to it, the rock will look like it's floating upward, even though it's standing still. And it's repelling sort of in the opposite direction of motion. So that's called the waterfall illusion. And they find the equivalent sorts of things for perception of valence, or valence perception. So the one I chose for today is an auditory perception, just to remind us that valence perception doesn't only happen in vision, but there are other cases with vision as well. So the one that I mentioned here is that voices, so they let people listen to voices. Voices were auditorily perceived as happier after adapting to angry voices, so positive when adapting to negative, and vice versa. So you listen to someone shouting angrily, and then you hear a neutral voice and it sounds happy. Or you listen to someone speaking in a nice happy voice, and then you hear a neutral voice and it sounds angry or negative in some other way. Okay, so these are all signals that what's going on here is not just a cognitive effect, but a perceptual effect. Okay, another one, and this is important for marketing of products and other sorts of commerce. Valence perception is sensitive to subtle details of the display. And again, this happens visually and in other modalities. Texture is a really important one too. So there's a series of studies here where they showed people images and they did different things to them. For example, they blurred them slightly, or they changed the sort of contrast at the edges. And what they found were significant, really big swings in how pleasant people rated them, but only based on these subtle details about things like whether the sort of edges were sharp or whether the blur was too much and so forth. Okay, last one, rivalry advantages. So rivalry occurs when in the visual system, when you present one image to one eye and another image to the other eye. And what you tend to find is that after a period of sort of chaos, you get one image dominates and then it kind of goes a little scrambled, and then you get another image that dominates. You never really see both images at once. So what researchers do is they study what factors drive these rivalry phenomena. What explains why one picture gets into conscious experience first, or what explains why one image gets in for longer. And what they find is that valence is definitely one of those factors. So during binocular rivalry, they showed people smiley faces, and the smiley faces that were sincere, so they're called the Duchenne smile, and they have like the crinkly sort of crow's feet at the eyes and the sort of upturned sort of corners. Those were perceived faster and for more time overall. And likewise for frowns that were sincere. So valence makes a difference to binocular rivalry. And the same thing happens for binaural rivalry in auditions. So if you play different things into one ear and the other, different things will dominate depending on their valence. Okay, so those are the hallmark. Oh shoot, I know how to fix this though, so we're okay. Every once in a while, my thumb migrates to the wrong button. Okay, so there's lots more results. And I think that's important because in psychology, if you only have a couple results, you can doubt because there's questions about replication, but these results are secure. So that establishes that evaluative perception meets the hallmarks of perception. Okay. Now, let's talk a little bit about feature binding. So far, we have evidence for valence in perception. That tells us that there's a kind of positivity and negativity in perception. But that does not yet get us to evaluative perception, because evaluative perception says that perception represents things as being good or bad. And all we've been talking about is it's pleasant or unpleasant to undergo the experience. And those are different things. So why should we think that having an unpleasant experience is a way of representing the thing that's causing the experience as bad? Why should we think that having a pleasant experience is a way of representing it as good? Okay, so that's what we're going to talk about now. So the question that I've used in my recent work to try to address this is, well, let's look at how other feature representations behave across a number of experiments. And let's ask, does perceptual valence behave like a representation of a feature? So there's lots of features, colors, shapes, orientations, and so forth. What do they do? Does valence do that too? Does it act like representations of those other things? And the answer turns out to be yes. And the context that I'm going to focus on is feature binding. So when you look at this screen, you see some redness, you see some greenness, you see a square, you see a circle. But you don't just see redness and greenness, you see the redness bound to the square. You see the square and the redness together, and that's called feature binding. They're bound together as features, and they're bound to one object. And likewise with the green circle. So in feature binding, we perceptually represent features as bound together and bound to objects. And that helps us do a lot of things. It helps us form beliefs about the objects. You know, it's like if you just had redness, you would have to figure out, what is this redness doing? But now that I know it's part of the square, I know what to form my belief about. It helps us with object tracking. So as an object moves through space, you get a kind of bundle of features, and as the features change, you still have this little file for the object that allows different features to come in and out, and that's object feature binding. Okay, so across many experimental settings, valence behaves like a representation of a feature bound to other features, uncontroversially perceptual features, and to objects. Okay, so here again, I'll just sort of breeze through some of the results to give you a feel for it, but if you want to ask more questions later, I would love to talk more about it. So one of the classic findings for feature binding is object-specific preview benefits. So here the idea, if we walk through the sequence from top left to bottom right, you start by fixating at the center of some screen with nothing else on the screen. Then, for some period of time, two images are flashed, right and left, with different features on them. In the classic case, it'll be like a red square and a green circle, but for valence, it'll be something like a face with a smile or a frown, or other kinds of things like a spider or a flower, other kinds of valenced stimuli. Okay, so that you look at that for a bit, then the features disappear, the objects move around, and then when an object is given a new, like a feature flashes back on an object, the finding of object-specific preview benefits is that if you previewed that feature, you're faster to detect it, so you have to have previewed it. But what's crucial is that if you previewed it on that very object, you're even faster and more reliable. So previewing it specifically on that object before the object moves around means that you're faster to detect it later. And we find that for valence. We find that if the smiley face was previewed on this object and then it moved around, you're faster and more accurate to detect it. But also if a spider was previewed here and then a negative face was flashed here, so it can change the stimuli but keep the valence as negative, you're still faster and more accurate to identify. And that last alteration, the one where you change the stimulus but keep the valence and you still get the effect, that's really striking because it suggests that the perceptual system is tagging face features, other kinds of things, but also the valence is its own separate tag. And so if the valence stays the same and if that's part of the task, then you're better at performing the task. Okay, there's a bunch of other results. So partial repetition costs is a classic paradigm where if you repeat all the features of an object, then you get the fastest and most accurate response. And if you change some of them but keep some of them the same, so you have a partial repetition, then you get a cost, lower accuracy and lower and longer response times. And if you add in valence as one of those features, so you repeat some features and not others, including valence into the story, you get the repetition effect. So changing the valence but keeping the other features the same, largely the same, gives you a partial repetition cost. Illusory conjunctions is another thing. So if someone is sort of like using cognition to decide whether something is good or bad, then what will tend to happen is they will see the thing one way, but then they'll make a judgment about it. And so the seeing will stay the same, but the judgment might change over time. Here, though, with illusory conjunctions, the classic finding is that when you give someone a cognitive task, so they're supposed to add two numbers on either side of a stimulus. So their attention is divided, their cognitive load is higher. When that happens, they often will bind features in an illusory way. So if you show them a red square and a green circle, they won't see a blue square, but they will often see a green square and a red circle. They'll sort of mix up which features they're binding together, but they won't invent totally new features. And that also happens for valence. So if you show someone a negative and a positive face, and then you have one of the faces be a black man and another one be a white man, there are predictable patterns where they see the black man as having a negative facial expression more often, even when he didn't have that expression. But they don't see it if both of them were presented with positive faces. So it's not like they're just more likely to see black men as having a negative face all the time. If they have both smiles on, it's not like they hallucinate a negative expression. But if there was one negative and one positive, it often gets switched into that order. And that's an illusory conjunction. Okay, attentional effects. So here, a bunch of several psychologists showed people's smiley faces and frowny faces with brightness variation, so light and dark. And what they found was that as they performed a task of asking, is it bright or is it dark, there was an interaction effect between the valence and the brightness. So if it was dark and negative, they were more accurate. If it was bright and positive, they were more accurate. But if they were mixed, they had longer response times and were less accurate. So again, binding these features together in an object-based way. And lastly, and this is pretty small, so I'm not sure you'll be able to see it, but there's a classic finding from very early visual processes. So only 129 milliseconds into visual processing, which is very short, just a little bit more than a blink of an eye. So here the task is this. You fixate at a central cross, and then you're shown a bunch of images. The classic one is things like numbers or letters. And the classic finding is that visual iconic memory, so picture-like memory, stores more objects than we can retrieve all at once. Okay, so what happens is that you show someone like an array of, say, 12 or 8 numbers, and they can't report all of them back to you. But what they can do is if you show them all 12 and then they go away, and then you cue them with an arrow and say, tell me the one that was at the end of the arrow, that they can do. So they can't retrieve all of them at once, but they can retrieve any of them given the appropriate cue. So somehow in this very fragile visual memory, all of that information is available, but only some of it can be pulled out. And that happens for valence. So if you show someone a range of images, some of which are positive, some of which are negative, and some of which are neutral, they are better at pulling out the information that's negative and pulling out the information that's positive than the neutral information. So valence is giving some kind of prioritization to which images can be pulled out of this iconic memory. And that suggests that valence is tagging to that item or that location at super early visual processes. Okay, so what do we have? We now have reason to accept evaluative perception. It's this idea that perception of valence or valence perception behaves like perception of other features because it has all of these experimental findings that are familiar for other kinds of feature binding results. Okay, so that's where we are so far. Yay, we established evaluative perception, unless maybe you have questions or concerns in the Q&A. Okay, so now let's pivot. This has been kind of science heavy. Let's talk more about like sort of traditional philosophical concerns. So what are the accuracy conditions for evaluative perceptual relations? In other words, if we have this idea that perception represents things as good or bad, what does that mean exactly? I mean, goodness and badness, that's pretty vague. Can we say more about when an experience of something as good is accurate, when an experience of something as bad is accurate, or is it very subjective? Okay, so valence and accuracy. So go back to the square and the circle. And we'll talk a little bit about accuracy conditions for perception in general. A representation of an object as being a square is accurate just in case the object is a square. Okay, so now this seems almost too boring to say, but you got to start somewhere. So that works great for certain kinds of features. Square, orientation. If a line is oriented vertically and you perceive it as vertical, accurate. If it's oblique and you perceive it as vertical, inaccurate, at least to that extent. Color's a little harder. Okay, so we won't talk too much about color, but I just mentioned that philosophers have talked a lot about exactly what does an object have to be in order for a color experience of that object to be accurate. It's not totally clear. One thing philosophers have often said is, there are certain wavelengths of light and surface reflectance properties that reflect those wavelengths, and red is a representation of a certain reflectance property, and green is a reflectance property of another wavelength. Maybe that's right. That's pretty complicated, and for our purposes, let's set that aside for right now. We've got our hands full with valence. Okay, so a representation of an object as good is accurate just in case the object is good? What does that mean? Okay, there are many ways things can be good or bad. It can be morally good, it can be aesthetically nice, it can be delicious, it can be brutal. There's just so many things that are evaluative. I don't think we can stop with just saying, my view is that it's accurate just in case it's good, because there's just too many kinds. Call that the plurality problem. There's a plurality of kinds of goodness and badness. Okay, another problem in this vicinity is that perceptual valence experiences and valenced experiences in general vary widely across agents and times and contexts. So Dinah's gustatory eggplant experiences are pleasant. When she eats eggplant, delicious. Ethan's gustatory eggplant experiences are deeply unpleasant. He hates eggplant. But that's just one stimulus. They're totally on opposite valence ends. What's going on? Ethan's visual experience of redheads used to be pleasant, but this changed after a hideous encounter with John, who is a redhead, and now, whenever Ethan sees a redhead, it's unpleasant for him. Sometimes Dina likes vanilla ice cream better. Other times she finds chocolate ice cream tastier or more pleasant. So that varies with time. Okay, so call this the variance problem. So we've got the plurality problem. There's just tons of different kinds of good and bad. There's the variance problem. There's all kinds of variety in our experiences of pleasantness and unpleasantness across agents, times, and contexts. Can we give a sensible account of the accuracy conditions for valence experiences given these two problems? Okay, so recently, several philosophers have raised these kinds of problems and said, this is fatal for evaluativism. No evaluativist can give an account that handles these problems. And it's not too far off to say that the counts that have been offered so far do pretty poorly along these lines. So for example, one account from Peter Carruthers at the University of Maryland says that all valences represent contribution to inclusive fitness. So the contribution to how well you are in reproducing and surviving through your sort of passing on your DNA. And then other sorts of related cultural things that are part of that process. So that's inclusive fitness. And he says every valence is really just a representation of something's contribution to the overall global inclusive fitness for you. But that seems like it doesn't handle variance very well. I mean, if people are finding these things very widely positive or negative, so eggplant, for example, seems like eggplant is healthy, so it should have a sort of broadly maybe inclusive fitness. It doesn't seem that plausible that it has both a highly positive and a highly negative for two people even across time. Okay, so Carruthers basically has to say that our valence experiences are wildly inaccurate. They're just getting things wrong all the time. And that's a cost, according to a lot of people. And there are other kinds of problems as well. So what I want to offer today is a new account of valence evaluativism that tries to solve these problems. Okay, so to do that, I'm going to appeal to reference standards. So personal or subpersonal preferred or goal or desired states. Okay, so reference standards include nutrient levels in the body. So you have like your sort of homeostatic processes in your body try to maintain certain salt levels and sugar levels and water levels, body temperature levels. So if you get too cold, that's outside the range of acceptable. If you get too hot, that's also outside the range of acceptable. Safety, so if the bear charges you, not acceptable. Bodily integrity, so if something punctures you, not acceptable. Social arrangements, so preferred bonding. And this can include temporal extended ones. So like if you haven't seen your friends in a while, that'll feel negative. If you've seen your friends too much, that might also feel negative. But if you've seen them in the sweet spot, that's great. Maybe the better example is with your family. Tranquility. So, the example of someone getting pushed or punched on the street, maybe you have a kind of reference state for, you want it to be broadly tranquil. Maybe you can accept some forms of violence, but they have to be certain kinds of contexts. Okay, aesthetic profiles. So there's really cool work from the early 2010s by someone named Sophie Lebrecht. She studied something called microvalences. She showed people pictures of phones, pictures of teacups, pictures of all sorts of ordinary objects, and she asked them to rate their valence for them, how pleasant or unpleasant. And what she found was that there are actually substantial patterns that people tend to prefer some kinds of objects over others. So for example, with teacups, they prefer smoother, symmetrical teacups with a certain size of handle. If it's lumpy or asymmetrical or looks rough textured or spiky, they disprefer it. Okay, so aesthetic profiles are another example. Okay, now there's a lot of different potential reference standards. For perceptual valences, those reference standards are probably narrower than the total set of reference standards that we have in our overall emotional life. But these are decent candidates for perception even. Okay, so now I want to introduce a concept that's familiar from philosophy of language and some discussions of mental representation called two-dimensional meaning or two-dimensional semantics. Okay, so we've got a little thing in the top right corner, you are here. So consider indexicals, terms in language or thought, such as here or I or you. Okay, so let's focus on here. The primary content of an indexical is a function that maps possible contexts of utterance or representation to secondary contents. Okay, and then secondary contents are a function that maps possible worlds to extensions. Okay, now that might sound incomprehensible. So let's talk about it, the example. So here. So in the word here, it has kind of two dimensions of meaning. One dimension of the meaning is constant across all contexts. That's the primary content. It's the fact that in any context that someone says here, it picks out the location of the utterance. So whenever you say, I am here, you're talking about where you are. Or if you say, you are here, you're talking about where you are, where I am, where the speaker is. Same thing with I. It always refers to the speaker. Same thing for today or now. It always refers to the day of utterance or the time of utterance. Okay, so that's indexical primary content. So there's something about indexicals that never varies across contexts, except there's also something that varies, and that's the secondary content. The secondary content says, once you have fixed the context of utterance, so once you know who the speaker is or where the speaker's utterance is occurring, then it can pick out the further information. So in the case of here, once we've fixed the location of the utterance, then we have the secondary content. It's location, say L, in this room. Then when I say we are here, my utterance is accurate in the secondary content way if we are in fact at location L. Okay, so that's indexicals. And what I want to propose today is that valence works like that. So valence has two-dimensional content. So the primary content for valence works like this. Regardless of which reference standard is operative, so you have all these affective systems in your mind, regardless of which one is operating, whether it's gustatory sort of deliciousness or social sort of like tranquility, regardless of which one is operative, positive valence represents the facilitation of the operative reference standard, whatever that standard happens to be. It's kind of like here. Any mention of here means the location of the utterance, whatever that location happens to be. And negative valence, likewise, its primary content is that whatever is the operative reference standard, it's being frustrated. Okay, so we're like outside the tolerated zone and things aren't going well. So think about body temperature. If you're too cold and you have a negative experience, the primary content is just the operative reference standard is not being facilitated, it's being frustrated. We're too far away from the homeostatic set zone. But the secondary content fills in the context and it fills in the actual reference standard. So valence secondary content says with the operative references are given by context, positive and negative valence represents facilitation or frustration of R. Okay, and now context here is a little different from indexicals because in philosophy of language, we have our conversational context. So we're all sitting in this room together, and so we're part of a conversational context, and things that I do to gesture, that's part of the context. But we also can establish a kind of context for valence. Here the context is fixed by the valence computational architecture. So for example, when a stimulus comes in, then different sorts of systems are consulted. So if you taste some salt, if you're low on salt, then the sort of salt levels in your body are actually in sort of real time, they're checked. And if you're low on salt and you're ingesting salt, then you'll experience that salt as good. And if you've had too much salt, you've just been eating potato chips all afternoon and you've gone way too far, then they start to taste less delicious. And that's because valences are in many cases sensitive to these internal states of your body. And that means that the reference state is playing a role as a kind of check for the valence computation. Okay, so one way the architecture can fill in the context here is with like real-time comparisons between the actual reference state and the current state like of ingesting the potato chips. Another way it can do it though, and this is probably especially relevant for perception, is that templates will be stored in the perceptual system. So we know that templates are stored in the perceptual system more or less because we can perceive things like faces, and that's roughly on the analogy that there's a kind of template for what a face looks like. And so you check the stimulus against your template, and that gives you a sort of sense of whether there's a face present. But the template doesn't have to be a changing reference standard in some sort of more general way. It could just be something very simple, like if an object suddenly appears close to your face, no matter what that object is, that's a form of looming. And looming might just be negatively experienced because it fits a template for it's violating a reference standard. This change is moving us away from some kind of safety standard. The perceptual system doesn't have to know too much about what's going on with that. It just has to store a template that says, when this happens, when something just suddenly occupies a large region close to my face, bad. Okay. So now we have what we can call reference relative evaluativism, or ref-rel evaluativism. And we can return to our two problems of valence. So the first problem was plurality. There are many kinds of goodness and badness. And we can solve that problem because there are many reference standards. There's nutrients, there's temperatures, there's safety, there's affiliation, there's tranquility. And so goodness now gets indexed to whatever reference standard is operative. Goodness in what sense? Well, a good temperature for me, like the organism that I am. Or nutrient levels. So is it a good amount of salt? Okay, so that helps us with the plurality problem. How about the variance problem? So remember that valences vary widely across agents, times, and contexts. But also, reference standards for each valence can shift across agents, times, and contexts. So if you prefer eggplant earlier in your life and then you come to get sick of it, that may be a kind of perceptual learning where the reference standard is shifting over time. Or the context might matter, or the time might matter. And then also conditions relative to one standard change too. So for example, you don't have to change the reference standard to get variance across time or context. So for example, I mentioned earlier, if you're salt depleted, you're really, like your body levels are low on salt, then as you eat salt, it facilitates the movement toward the desired salt level, the reference standard, and so it will taste good. And if you're already salt saturated, then ingesting more salt frustrates satisfying that standard, and so it'll taste bad. Okay, the last part of the talk. So hopefully you're still with me. You've got the sense that we might have pleasantness and unpleasantness in perception itself at the very ground floor of the mind. And we have some reason to believe that what's going on there is that the perceptual system is representing things as good or bad. And finally, we have a sense for what that means. It's representing them as good relative to an operative standard, or bad relative to an operative standard. So I want to make just a small suggestion about how this might help us explain and maybe even mitigate against or resolve some forms of social disagreement. So we know how to argue over matters of fact. I mean, maybe not well, but we at least have some sense of how to do it, or at least we should. And that is, we should use perception and explanation and some other tools. If we disagree about where the car is parked, then we can go out and look for it. And if we get to the car and my clicker opens the door and you say, that's not your car, and I say, my clicker works, the explanation is that it is my car. At some point, it's rational to accept a resolution to the disagreement and irrational to continue to disagree. We also know, or at least should, maybe, know not to argue too much over matters of taste. What should we do instead? Well, tolerate where you can, negotiate otherwise. So, without understanding how evaluative perception works, we can get confused about how to solve social disputes that arise from conflicting evaluative perceptions. So remember our case from earlier. While walking across the street, you witness a person push another in an attack, and the sight is deeply unpleasant to you. Okay, so let's introduce two people in this scenario, and let's add a further detail in the background. Let's say that the person who gets pushed belongs to group G, okay? So an older person or a person from a certain ethnic group. Dina prefers violence toward people in G. Ethan prefers nonviolence toward people in G. They have different reference standards. And now, if Dina and Ethan perceived the scene in the same way, which is not what's happening here, but if they had, but only differed in their reactions based on preferences, in other words, if they saw the same stuff, but had a different reaction to it, they would, or at least maybe should, know how to negotiate their preferences. It would be sort of more transparent to them that, okay, I hate these people, you love these people, what do we do about that? But at least we can agree on what happened, perceptually. But that's not, at least what I've been arguing today, what happens here. Instead, Dina's perception represents the event as good. And Ethan's perception represents the event as bad. And that's perception. That's at the ground floor of the mind. So without knowing more about evaluative perception and how it works, it may be reasonable for them to say, at least initially, Dina can say, I can just see that it was good he got pushed. There's no reason to negotiate or argue. I can just see it. And Ethan can say, you're right about one thing. There's no need to argue or negotiate, but you're wrong about another. It was bad. Anyone could see that. Maybe you weren't paying attention. So it's a new layer to social disagreements that I'm suggesting may exist. We already know that we have different reactions to things. We already know that we have different preferences and principles, social commitments, and other sorts of things. But maybe we didn't realize that even perception can help steer us into these disagreements. So value disagreements that can stem from perceptual differences. One person perceives an event as good, another perceives it as bad. Without knowing more, it can seem that perceptions should settle the matter, or that perception is a matter of taste to be negotiated. By understanding evaluative perception at least a little better, we're equipped to understand the nature of these disputes and maybe make adjustments to the reference standards themselves once we understand the role they're playing that give rise to these disagreements where we are willing and able to do so. Thank you.